All right, welcome back, everyone. So in the last section, we talked about how to do hypothesis tests with t-tests when you have a single sample and you're trying to answer a question about mean values when you don't know the population standard deviation. Okay, in this last section, we're going to talk about how to do hypothesis tests when you have a sample of proportions, right, or a single sample of proportions. So we're going to talk about, again, how to do this with the critical value method and the p-value method. Okay, remember our assumptions for proportions and remember how to calculate the z-values for proportions. We go back to using z-values in this case because of the way that the data vary. And again, the proportions can only vary in so many ways compared to how many different ways samples can vary or means can vary. So just be aware of that. You got to change the equations a little bit. But to calculate z for our z-test, it is the sample proportion minus the expected population proportion divided by the standard error of the sample proportions, which is this value here. So let's take a look at some examples. And again, we're going to go through just the same steps of hypothesis tests. The Pew Research Center reported that only 15% read a daily newspaper. The publisher of a local newspaper wants to know whether that percentage at a nearby university is different from the percentage of students in general. She surveys 200 students, finds that 40 of them, or 20%, read the newspaper each day. Can she conclude that the proportion of students who read a daily newspaper differs from 0.15? And so this very much tells us a good bit about our hypotheses, but let's start from there. So our null hypothesis is that there's no difference, right? They're equal. There's no difference between the students in the university and everybody else. Right? We always start from assuming everything is equal. So we assume that the sample proportion in this case, and we would use a p, is going to be equal to 0.15. The alternative hypothesis is that the proportion differs from 0.15 or it's not equal to 0.15. And so now we have our hypotheses, right? We're going to start by assuming the sample is equal. And if we find that that's really unlikely, we'll use our alternative. Now we want to calculate our test statistic. We're going to need a few things here. The expected proportion in this case, and I should maybe just write it as we had it with p, was 0.15. Okay, the sample proportion, and that's why it gets the hat over it, is 0.20. We know our sample size is 200. Now, when we calculate the standard error or the standard error of the sample proportions, we want to use this population value, and not the sample value that you have here, to calculate the first part. 0.15, 0.85, that would be 1 minus p divided by 200. And our standard error value here is 0.0252. And now, to find our test statistic, we need z. That's going to be our sample proportion minus the expected proportion, or the one we're comparing it to, divided by the standard deviation, or 0.15 minus, 0.20 minus 0.15 divided by 0.0252. We get a z-value of 1.984. We'll go with 1.984. So this is our sample test statistic. If we want to determine if it's significant, we're going to use the critical value method here. So we want to find our critical z-value. The critical z-value with an alpha level of 0.05. Remember that we're looking for a difference. So in that case, we want 2.5% on one side, 2.5% on the other side. If it was greater than or less than, it would all be on one side, which means that if we want to know this z-value here, that marks our rejection region, that marks the boundary, the critical z-value, then we want to find the z-value for where there is 97.5% of the area to the left. To do that in Excel, equals norms dist, other way around, equals norms INV, and then you plug in 0.975. That'll give you the area to the left. And if we do that, 1.9, our other z-value was 1.984. Okay, notice that our critical z is then just a little farther past this point in the rejection region. Not much, but it is past the boundary, and that's all you need. And so, because it's in the rejection region, it's greater than the critical value. We will reject the null hypothesis. There's evidence to conclude the proportion of students at the university reads the paper, the proportion, there's evidence to conclude that the proportion of students at the university who report reading the paper is higher or it's different from 15%. I don't want to try to write all of that out while I was trying to say it. But again, there's evidence to conclude, and then you talk about the, went one too far, you talk about the alternative hypothesis. There's evidence to conclude that the proportion of students who read the paper is different from 15%. I left out some of the descriptor words that they had in the example. Let's look at one more. A stent is a wire mesh tube that's replaced in a blood vessel to keep it open. A total of 1,120 patients received this new kind of stent for a blood vessel. Of these, 134 required additional treatment within a year. Can you conclude that less than 15% of these patients required additional treatment? Okay, we're going to use an alpha level of 0.01, and then we're going to use the p-value method as well. So let's go back here. First of all, let's start with our sample size is 1,120. The population value we're comparing it to is we want to compare it to 15%, 0.15. Okay, we need the sample proportion here. We only know the number of patients. So to find the sample proportion, it's 134 divided by 1120, 0.120. So now we need to calculate. Well, I've gotten a little ahead of myself here, but now we have the sample proportion. Let's start with the hypotheses. Our null hypothesis is that the proportion is equal to 0.15 or 15%. The alternative hypothesis is that it is less than, right? Can you conclude that less than 15%? And so we want to determine if it's less than 15% using our hypothesis test. The next step is to calculate our test statistic, which is Z again in this case. Our sample proportion minus the value we're comparing it to divided by a standard error value, which we have to calculate. We do that using 0.15, 0.85 divided by our sample size is 1,120. And so when we plug that in to get our sample calculation or our standard deviation, when you plug this into the calculator, you should get 0.0107. And so now to calculate Z, our sample proportion was 0.12. The value we're comparing it to is 0.15 or 12% and 15%, 0.0107. This gives us a Z value of negative 2.804. Now that we have our test statistic value, we want to find the significance. To do that, let's see, Z is negative 2.804. So that's going to be way over here. Here's our Z value. We want to find the probability. To do that in Excel, equals norms dist. Remember, this gives us the area to the left, which is what we're looking for, the area that's less than. Norms dist of negative 2.804. And that gives us a probability of 0.0025. Okay, remember that our alpha level in this case is 0.01 or 1%. And so the probability is much less than our alpha value. If the probability is less than the alpha value, then it's a rare sample. It's unlikely to have happened by chance. And so we reject the null. And we can conclude, there's evidence to conclude that the proportion of patients who need additional treatment after a year after having the stent is less than 15%. I'm going to try to write all of that down. Okay, but remember that there is evidence. You always want to write everything in terms of the alternative at the end. So our alternative hypothesis was this. And so again, there's evidence that the proportion of patients who need additional treatment is less than 0.15 or less than 15%. Get one more example here. Gallup poll asked 1,115 U.S. adults whether they believe that people should pay sales tax on items purchased over the internet. 437 of them said they supported a tax. Does the survey provide convincing evidence that less than 45% of U.S. adults favor an internet sales tax? And so first, let's start with our hypotheses. Okay, I missed the number up there. Let's start with our hypotheses. The null hypothesis is that the proportion is equal to 0.45. The alternative is that it is less than 0.45. And so remember, this is the proportion of people who favor a tax, right? These are the proportion who said yes. Again, we have to find our sample proportion. So let's do that in the next part. To get our Z value, we need the sample proportion. 437 divided by 1015.431 to find the standard deviation value or the standard error. That is the square root of 0.545 times 0.55. Remember, we're going to use the population values here. divided by the square root of, divided by n, and then we take the square root. When you plug that into the calculator, we get 0.0156. So to find our test statistic, to find z, it is the sample proportion minus the proportion we're comparing it to, divided by the standard error, or 0.431 minus 0.450, divided by 0.0156. And our z value here, negative 1.218. And so now we have our z value. We want to determine if it's significant. So just to make it a little simpler, our z value was negative 1.218. So let's go ahead and put that here. Negative 1.21. Here's our z. We either need to find the probability, okay, which you can do using equals. Remember, we're looking for less than, so we want the probability to the left. So equals norms dist. We don't have to worry about subtracting or anything. Negative 1.218. And that'll give us this probability. Or we can find our critical z value, which again, you can use a table or something like that. Or you can use Excel. And you can find the critical z value, norms I and b. Okay, and in this case, to find the probability here, we have a 0.05 level of significance, which means we want 5% on this side on the left, because we're less than. So we want this part of the normal distribution curve. We want 5% to the left. We would put 0.05 here. And we're going to find the answers to these real quick. So the probability is 0.1116, or about 11.616%, okay, which if there's 5% here, right, it should be kind of clear where z is. For the critical z value, this one is likely familiar. Let's just check. Negative 1.645. Okay, so our z is not in the rejection region for the critical value. It's closer to the mean than the critical value. Okay, so this tells us that it's not an unusual sample. The probability is 11.16%. So this tells us that it's not an unusual sample. And so we fail to reject the null. There's no evidence to conclude that less than 45% of the adults favor a sales tax. If you have any questions about these, please let me know. In the next sections and in the next chapter, we'll talk about how to compare multiple samples to one another using proportions and using sample means, and how to compare one sample to itself at different points in time. Some of the most common research questions that we can answer. If you have any questions, please let me know.